Welcome to the deep dive. Today, we're going to be exploring deep learning.
Oh, yeah.
Deep learning.
It's
I mean,
every
it really is everywhere. Self-driving cars, talking to our phones, all that.
it's incredible how much it's grown, like even just in the last couple of years, like
Yeah.
healthcare, finance, entertainment.
Oh, yeah. It's really everywhere.
Yeah.
And we're going to try to break it all down. How it works, why it's so powerful, maybe some of its limitations.
hmm
You ready?
Absolutely. Yeah. Let's start with the foundation.
Okay.
Neural network.
Neural networks, they're modeled after the brain, right?
That's the idea.
Okay.
Like billions of neurons.
Yeah, billions of neurons, all interconnected.
Yeah, and in deep learning, a neural network, tries to mimic that. So think of it as a network of nodes,
Okay.
organized in layers. Each node represents a neuron.
Okay, so like if we imagine a neural network trying to recognize a cat in a picture,
Right.
what would that look like?
Well, you might have one layer of nodes that is focusing on detecting edges in the picture. And then another layer would focus on shapes.
Okay.
And then another layer might be looking for very specific features like whiskers or ears,
I see.
So each of those nodes is processing information
Yeah.
and passing it on to the next layer.
Okay, so each node takes in information, does some math, spits out a result, and then passes it on.
Exactly.
Right.
Okay.
So then where does the deep learning come in?
Well, the more layers you have,
Okay.
the deeper the network.
So it's like adding more levels of analysis.
Precisely.
Okay.
And this depth allows the network to learn increasingly complex representations of the data.
Okay.
It's what allows it to excel in tasks like computer vision, where recognizing a cat is much more than just recognizing shapes and colors.
Right.
It's also about context and texture and all these other features.
Right. So more layers equals more sophisticated understanding.
Yeah, in essence, yeah. The first layer might just be detecting simple edges, but then, subsequent layers will combine those edges to recognize shapes. And then those shapes to identify features
I see.
like eyes, ears, and then, eventually put all that together to recognize the cat.
Okay, that makes sense. It's like those puzzles where you start with a bunch of seemingly random pieces, but then you put them all together and it creates a whole picture.
That's a great analogy, yeah.
So how does the network actually learn to recognize the cat?
Well, it's not really programming in the traditional sense.
Okay.
It learns through a process called training.
Training. Okay.
Yeah. So we feed the network massive amounts of data, in this case, images of cats.
Okay.
And each time the network processes an image, it compares its output.
Okay.
Like, it's basically making a guess, is this a cat or not?
Right.
And it compares that to the correct answer.
Okay.
And if it gets it wrong, it adjusts the weights of the connections between its nodes
Oh, interesting.
to improve its accuracy for the next time.
So it's constantly refining its understanding.
Yes, and it's doing this for millions, even billions of parameters within the network. This process, just repeated over and over and over,
Okay.
is what allows the network to learn to recognize a cat, even in images that it's never seen before.
That's incredible. But it also sounds super complex.
It is, and that's actually one of the reasons why deep learning requires so much computational power
Okay.
and such massive data sets. I mean, we are essentially trying to mimic the complexity of the human brain,
Yeah.
which is no easy feat.
So we've got these really intricate networks, but they come in different forms too, right?
Exactly. Within deep learning, there are different architectures
Yeah, okay.
designed for specific tasks.
So different specialists.
Yeah, think of it like different teams of experts all trained for a particular mission.
Okay, give me an example.
Okay, we'll take convolutional neural networks, or CNNs. They're particularly good at image processing.
Oh.
They use filters to scan images, extract features, and piece them together to recognize objects.
Okay.
So, our cat detecting network, if it were a CNN, it would be scanning the image, identifying those edges, those shapes, and ultimately the cat.
Okay. And what about other types of networks?
Right. Well, another one is the recurrent neural network, RNN.
Okay, RNNs.
RNNs, these are the memory masters.
Yeah.
They have a memory of previous inputs,
Okay.
which makes them perfect for tasks like speech recognition,
I see.
where the context of a sentence is really important for understanding.
Right. So they're not just analyzing the individual words, they're also remembering what was said before.
Yeah, exactly. So, for example, if I say, the cat sat on the mat,
Yeah.
an RNN would use its memory to predict that the next word is likely to be mat or chair or something like that.
Oh, that's interesting.
Yeah, so different architectures for different tasks, and it seems like the possibilities are almost endless.
Yeah, the possibilities do seem endless, and we've only just begun.
We've really just scratched the surface.
Yeah, this is fascinating. Thanks for breaking that down.
Of course.
So we've learned about these incredible networks, but, how does this all translate into the real world?
Well, that's what we're going to talk about next time.
Okay, sounds good.
We'll dive into the world of computer vision
Yeah.
and all the ways that deep learning is making computers see in ways that we never thought possible.
I can't wait. See you next time.
Sounds good.
Welcome back to the deep dive. Last time we got into like the real nitty-gritty
Yeah.
of deep learning, neural networks, all those architecture.
When I talked about how they learn
Yeah.
from tons of data.
Right. And now I'm really excited to see how all of that translates to the real world.
Yeah. Yeah.
So where do we start?
Well, let's jump into the world of computer vision.
Okay.
This is where deep learning has really made its mark. Computers can now see and interpret images.
Okay, so how is deep learning changing how computers see?
Well, remember those convolutional neural networks?
Yeah, the CNNs?
CNNs, right. They're the workhorses of computer vision. Their ability to analyze images, extract features, and recognize patterns.
Yeah.
It's really revolutionized everything. Okay.
From facial recognition to medical imaging.
So those filters that we talked about, they're like little digital detectives, right?
Exactly. They're scanning those images for clues.
Okay.
Let's take facial recognition as an example.
Okay.
So CNNs can analyze an image of your face, detect key features, like the distance between your eyes, the shape of your nose, and all of that,
Uh-huh.
and use those features to create like a unique digital fingerprint.
And that's how my phone unlocks when I look at it.
That's one application.
Okay.
But facial recognition goes way beyond that. I mean, it's being used in security systems, law enforcement, even social media
Right.
for tagging people in photos.
Yeah, it's amazing how accurate it's gotten. Like, I remember when facial recognition was kind of like a gimmick,
Right.
and now it seems like it's everywhere.
It's everywhere, and it's only getting more sophisticated.
Okay.
Deep learning is enabling these systems to recognize faces, even in like really difficult conditions,
Oh,
like
duh.
low lighting or from different angles. That's pretty amazing. I've also heard about deep learning being used in medical imaging.
Oh, absolutely.
That seems like a huge deal.
It is. It is. It's a game changer in healthcare. CNNs are now being used to analyze medical images like X-rays, CT scans, MRIs,
Wow.
to detect diseases like cancer much earlier and more accurately than ever before.
So it's like having this extra pair of eyes, right? Like really skilled eyes,
Right.
assisting doctors with diagnoses.
It's more than that even.
Okay.
It's helping to personalize treatments.
Okay.
So by analyzing a patient's medical history, genetic information, imaging data,
Right.
deep learning can actually help doctors tailor treatments for that specific person's needs.
Like a personalized medical advisor.
That's a great way to put it.
That's awesome.
Right.
So deep learning's impact on healthcare is only going to grow.
Absolutely. I mean, we're already seeing huge breakthroughs in things like drug discovery,
Wow.
where deep learning is being used to find new drug candidates.
That's incredible. So it's not just about recognizing images, it's about understanding what they mean
Right.
and using that knowledge to actually like help people.
Exactly. Now let's shift from static images to moving pictures.
Okay.
Think about self-driving cars.
Oh, okay.
I mean, they rely heavily on computer vision to navigate the world.
Right. They need to understand not just what objects are around them,
Yeah.
but how they're moving.
Exactly. And that's where deep learning comes in. Deep learning algorithms analyze that constant stream of data
Okay.
from the car's cameras and sensors so the car can identify pedestrians, other vehicles, traffic lights, all the elements of that complex driving environment.
Yeah, it's like giving the car a brain,
Yeah.
to process all of that in real time.
And learn from it.
Wow.
Yeah, with each mile driven, the car's deep learning algorithms are getting better
Okay.
at recognizing patterns, predicting behaviors, and making decisions.
That's fascinating. And also kind of scary.
Yeah.
Like we're putting so much trust in these systems.
It's a valid concern, but I mean, the potential benefits are huge. Self-driving cars could reduce accidents, improve traffic flow,
Right.
increase accessibility for people who can't drive themselves.
It's going to reshape our world for sure.
Yeah.
Okay, so we've seen how deep learning is revolutionizing computer vision.
Yeah.
What about hearing?
That's where speech recognition comes in.
Okay.
And just like with computer vision, deep learning has totally transformed this field.
Yeah, I've definitely noticed a huge improvement in speech recognition
Oh, yeah.
in just the past few years. I mean, I remember when voice assistants could barely understand like simple commands,
Right.
and now I can actually like have a conversation with my phone.
And that's all thanks to those recurrent neural networks.
The RNNs.
RNNs, right? The ones with the memory.
Right.
They've revolutionized speech recognition
Okay.
by enabling computers to not just recognize individual words,
Yeah.
but to understand the meaning of entire sentences and even paragraphs.
So they're not just listening, they're comprehending.
Yeah, exactly.
Yeah, it's impressive.
It is, and it's led to some really cool applications. Think about real-time translation.
Okay.
You can now speak into your phone in one language, have it instantly translated into another.
It's like having a universal translator in my pocket.
It is, it is. Well, it's also being used to generate synthetic speech.
Oh, wow.
That sounds incredibly natural.
Yeah, those AI voices you hear in podcasts or audiobooks now,
Right?
they used to sound so robotic.
Totally.
And now they're like almost indistinguishable from a real human voice.
And that's just the beginning. Deep learning is being used to create personalized voices.
Okay.
Voices that can express emotions, even voices that can sing.
That's pretty wild.
Yeah.
So we got computers that can see, understand, and now talk.
I know, it's crazy, right?
What other areas is deep learning impacting? I feel like we've only just scratched the surface.
Well, we have. But in the next part of our deep dive, we'll explore some of the other amazing applications of deep learning.
Okay.
And we'll discuss some of the challenges and opportunities that this technology presents.
Sounds like a plan. Can't wait. Welcome back to the deep dive. It's been quite a journey so far.
It really has. We've covered so much ground.
Yeah, we've explored neural networks,
All
all those different architectures and how they're revolutionizing things like,
computer vision,
computer vision and
speech recognition.
speech recognition. It's amazing how far it's come.
I know, it seems like just yesterday we were struggling to get our phones to understand a simple command.
Right. And now they can practically write our emails for us.
It's true. It's evolving so fast. New breakthroughs are happening constantly.
Yeah, it feels like we're just at the beginning.
We are.
So where do we go from here? What's next?
That's the big question, isn't it? And the possibilities are really exciting. One area that's really gaining momentum is deep learning and robotics.
Robotics, so like robots that can learn.
Exactly.
Yeah.
Imagine robots that can perceive their environment,
Oh, yeah.
make decisions, even learn new skills through experience.
Wow.
Instead of just being programmed to do very specific tasks,
Right.
they can actually learn on the job.
So like robots working alongside humans in a factory,
Exactly.
adapting to changes and learning new things.
Or even robots that can assist with surgery,
Okay.
providing surgeons with like superhuman precision.
That sounds like something out of a movie.
I know it does, right?
Yeah.
It's becoming more and more real, though.
So deep learning is like blurring the lines between science fiction and reality.
It really is.
Okay. So we've talked about computer vision, speech recognition, robotics.
Yeah.
What other areas are being impacted?
Well, natural language processing, or NLP, is one.
Okay.
It's all about getting computers to understand human language.
So like reading, writing, translating.
All of that and more. Deep learning is making huge strides in machine translation,
Okay.
helping people from different cultures communicate more easily.
I see.
It's even being used to create chatbots
Right.
that can hold natural conversations.
Yeah, the ones that you can't even tell are bots anymore.
Exactly, and virtual assistants that can understand complex requests.
It really does seem like we're getting closer to that world where computers can truly understand us.
We are, and that opens up a whole new world of possibilities.
Personalized education.
Yeah,
More intuitive ways of interacting with technology.
absolutely.
It's really mind-blowing. But as with any powerful technology,
Yeah.
there are always challenges.
Oh, absolutely. One of the biggest challenges is making sure that these systems are developed responsibly.
Okay, responsibly, what does that mean?
Well, we have to be very mindful of potential biases,
Okay.
prioritize privacy,
Right.
and really ensure that these systems are being used for good.
So it's not just about the technology itself.
Right.
It's about our values
Exactly.
and the choices we make about how we use it.
It's a shared responsibility. Technologists, policymakers,
Right.
and everyday people all need to be a part of this conversation.
That's a lot to think about.
Yeah.
But it's exciting to be living in this time
It is. It is.
and seeing how deep learning is changing the world. Any final thoughts for our listener as we wrap up our deep dive?
Just this. Deep learning is a powerful tool.
Okay.
And like any tool, it can be used for good or bad. It's up to all of us to ensure that we use it to create a better future.
I like that. Well said. Thank you so much for joining us on this deep dive into deep learning.
My pleasure.
We hope you learned something and maybe got a little inspired to explore this amazing technology further.
Keep those neurons firing.
Yeah, keep those neurons firing. And we'll see you next time on the Deep Dive 5.